So this chapter is about vector, and in order for us to understand vector, we have to understand the difference between a scalar and vector. So what does scalar mean? A scalar quantity only consists of magnitude. So what does this mean? It means that, like, for example, your weight or your height or the length of this table, it has only a positive value. It doesn't have a negative value. So that's called scalar quantity. Or like your age. Your age only goes up. It never comes down. So vector consists of magnitude, as what we mentioned earlier, plus direction. So a vector is something that has a size, like a speed, direction, or strength. But we have to take into account the direction. And for example, if we have an arrow here, let's say this arrow originates from 0 and it stops at point A. And let's say we call this as a vector A. So we represent a vector A as like a bold A in your textbook. Or we can write it as an A with an arrow, that's fine. Or we could write it as vector OA. So we write it this way. And how do we represent the magnitude of the vector? So as we know, the magnitude or the length of the vector is really important. So the length, L-E-N-G-T-H, the length of the vector, we can write it as A with the absolute sign, or else this A with the arrow and the absolute sign, or the vector OA with absolute sign. If we have a vector that is another vector, if we have a vector that originates from B and it goes to A, we call this as a vector BA. So international students, you have to understand that this will be the position vector of A relative to B. What does it mean? When you look at the word relative to, it sort of means from B. So this will be a position vector of A relative to B. Also, how do we call this? We will say that this is a position vector of A. So position vector of A. Other than that, we have to understand the idea behind equal vectors. So let's say I have two vectors and they have the same length, they have the same direction. We call this as equal vectors. You need to keep this in mind later when we are solving the questions, because if we want to prove that something, like two vectors are equal vectors, they need to have the same length and they need to be in the same direction. So what if I have another vector of the same length and it's parallel, but it's going the opposite direction? We call this as a negative vector. So if I represent my vector here as vector B, this negative vector will be negative B. And also, we have to understand that for vectors that are like the same direction as B, but double its length, so like a vector here, we will call this as a vector 2B. And for a vector of the same direction as this one, but half the length, we call this as half B. And if it's half the length as well and it's in the opposite direction, it's negative half B. So the idea behind this is called scalar multiplication of vector. And other than that, we also have vector addition. What does that mean? For example, I have another vector called vector A, and it goes this way. And I have a vector B here, which is going this way. So if I combine these two vectors together in a blank space here, so I have vector A going this way, and I have vector B going this way. And you have to realize that when I draw the vector, they are sort of like of the same length and the same direction. So that's B, and this one is A, and so they should be continuous. So A and B gives us a resultant vector of this vector here. So this vector, we call it as a vector A plus B. So that's the resultant vector of A plus B. So this is vector addition. What if we have a negative B vector and we also have A? So if I have an A and I put it in a blank space right here, so it's the same vector, same length, same direction, and that's A. And I have a B, like a negative B vector. So this one is maybe here. So this is slightly longer, the same length, negative B. So the resultant vector for this one will be going here. So this is actually my A plus my negative B vector. So this will become A take B. So this is my vector subtraction. Okay, and what if I have a vector B, which is here, this one, from here to here, and this is vector B, and I also have another vector, negative B. So starting from here, which is the same point, and drawing back to here again. So if I have a vector B and a negative B, what is the resultant vector? The resultant vector will be B plus negative B will be 0. So this is actually called a 0 vector, meaning that the point initially that is from here has moved to here and back to where it originally is, and therefore it does not have a length or a direction. We call this as a 0 vector. If we need to form a vector equation, for example, I have vector A, vector B, vector C, and I have another vector D. I can form an equation by stating that vector D is equivalent to A plus B plus C. So that's called vector equation. So this is the basic understanding and concepts of vectors, and I hope that you will find this useful and that you really need to be writing your vectors in their proper notation in the next chapters and tutorial. Thank you.